Welcome to our deep dive. Today we're going to be talking about quantum entanglement.
Yeah.
So you already know the basics of quantum computing, things like superposition and qubits. But today we're taking it a step further
Yeah.
into a realm that even puzzled Einstein.
It's a phenomenon that seems straight out of science fiction,
Yeah.
but it's real, and it's at the heart of what makes quantum computers potentially so powerful.
Okay. So what exactly is entanglement?
Right.
Let's start simple.
So imagine two coins,
Okay.
but not just any coins. These coins are linked in a way that defies the everyday intuition.
Okay.
Every time you flip them,
Yeah.
they'll always land on the same side, either both heads or both tails.
Now that's already weird.
Yeah.
Because with regular coins, you'd expect a mix of heads and tails. Okay.
Exactly. But with entangled coins,
Yeah.
the outcome of one flip instantly determines the outcome of the other,
Whoa.
no matter how far apart they are. It's as if they're communicating with each other instantaneously.
That's where the spooky action comes in, right?
Yeah.
Einstein wasn't a fan of that idea.
He called it spooky action at a distance because it seemed to contradict his theory of relativity, which states that nothing can travel faster than light.
Yeah.
But here's the thing.
Okay.
No information is actually traveling between the entangled coins.
Hold on. I'm a little lost.
Okay.
How can they be linked without information traveling between them?
Think of it this way.
Okay.
It's not that the coins are sending signals to each other.
Right.
Instead, they share a deeper,
Yeah.
non-classical connection from the moment they become entangled. Let me give you another analogy that might help.
Okay. I'm all ears. Lay it on me.
Imagine you have a pair of gloves,
Right.
but they're separated by a huge distance.
Right.
If you find a right-hand glove,
Uh-huh.
you instantly know that the other glove must be left-handed, right?
Right. That's just common sense.
Exactly. But there's no need for any information to travel between the gloves for you to know that they were linked from the beginning.
Right.
Entangled particles are kind of like that.
Yeah.
They share a connection that transcends distance.
So if we apply that to the quantum world.
With entangled qubits,
Yeah.
which are the building blocks of quantum computers,
Right.
measuring one instantly reveals the state of the other,
Wow.
even if they're miles apart.
Okay.
And it's not that information is traveling between them faster than light.
Mm-hmm.
They share this unique connection from the moment they become entangled.
So how do we know this is real
Right,
and not just some bizarre mathematical quirk?
right.
Einstein himself was skeptical.
Well, Einstein wasn't alone in his skepticism.
Yeah.
Many physicists in the early 20th century struggled to accept entanglement. They thought there must be some hidden variables,
Okay.
some unseen factors that could explain these seemingly impossible correlations.
Yeah.
But then came Bell's theorem. This theorem, developed by physicist John Bell in the 1960s, basically proved that the correlations between entangled particles are stronger than anything that could be explained by classical physics,
Okay.
including those hidden variables Einstein was looking for.
So Bell's theorem basically sealed the deal for entanglement.
Exactly. And what's even more amazing is that physicists have actually demonstrated entanglement in the lab.
Really?
They can create entangled particles like photons using special crystals. These crystals split a single photon into two entangled photons with linked properties.
Right.
For example, they can create photon pairs that always have perpendicular polarizations.
Wait, so they can actually see this entanglement happening?
They can observe the correlations between these entangled photons,
Wow.
proving that the spooky action Einstein talked about is a real phenomenon, and it's not just limited to labs.
Yeah.
China achieved a groundbreaking feat with its quantum satellite experiment. They sent entangled photons to different ground stations over 1,200 kilometers apart.
Hold on, they sent them from space.
Yes.
Tell me more about this.
It was a major milestone.
Okay.
They successfully achieved secure communication using those entangled photons,
Wow.
proving that entanglement can be used for practical applications over record-breaking distances.
Okay. I'm starting to grasp the what of entanglement,
Mm-hmm.
but now I'm curious about the how do we actually create these entangled particles in the first place?
That's where things get really interesting.
Yeah.
One way to create entanglement is by using something called a quantum gate.
Okay.
Specifically, a CNOT gate.
A CNOT gate. That sounds pretty technical.
Yeah.
Break it down for me.
Think of it like a logic gate in a classical computer,
Yeah.
but with a quantum twist.
Right.
It operates on two qubits,
Uh-huh.
a control qubit and a target qubit.
Control and target. Got it.
Yeah.
So how does this gate create entanglement?
Here's the rule.
Okay.
If the control qubit is in the state 1,
Yeah.
the target qubit flips its state.
Okay.
But if the control qubit is in the state 0,
Mm-hmm.
the target qubit stays the same.
Okay.
Essentially, the control qubit dictates what happens to the target qubit.
Okay, so far so good.
Right.
But I don't see the entanglement yet.
Here's where it gets mind-bending.
Okay.
Imagine sending 2 qubits through this CNOT gate
Uh-huh.
with the first qubit as the control
Right.
and the second as the target.
Okay.
Let's say the control qubit is in a superposition state,
Yeah.
a blend of 0 and 1 like we talked about earlier.
Now things are starting to click.
Yeah,
Because the control qubit is in a superposition, it hasn't decided what state it's in yet.
exactly. And since the target qubit's fate is tied to the control qubit,
Yeah.
the target qubit is also forced into a superposition.
Okay.
It's like the target qubit can't decide whether to flip its state or not
Oh.
because the control qubit hasn't made up its mind.
So they become entangled, intertwined because of this uncertainty in the control qubit.
Precisely. Their fates are intertwined from that point on.
Hmm.
Measuring one qubit instantly reveals the state of the other, just like with our entangled coins and gloves.
Wow. So entanglement isn't just some abstract concept. We can actually create it and manipulate it using these quantum gates. That's incredible.
And that's what makes entanglement so powerful.
Yeah.
It's a key resource for quantum computers.
Okay.
It's what allows them to perform calculations that would be impossible for classical computers to handle.
I'm trying to wrap my head around that.
Sure.
Can you give me an example of how entanglement actually makes quantum computers more powerful?
Imagine you're searching for a specific answer within a vast database.
Oh, yeah.
A classical computer would have to look through each entry one by one.
Right.
But a quantum computer, using entanglement, can explore multiple possibilities simultaneously. It's like checking all the entries at the same time.
So it's like a massive speed up.
Exactly. This makes quantum computers exceptionally powerful for tasks like drug discovery materials, science, and breaking encryption.
This brings up a question that's been nagging at me.
Okay.
If we can entangle particles
Yeah.
and they have this instant connection, does that mean we could one day send information faster than light?
That's the million-dollar question.
Yeah.
While entangled particles seem to influence each other instantly,
Right.
it's important to remember that no information actually travels between them. The connection they share is beyond our classical understanding of space and time.
So the idea of faster than light communication is still off the table.
It's a question that physicists are still grappling with.
Okay.
There might be fundamental limits we haven't yet discovered.
Right.
The true nation of entanglement and its implications for our understanding of the universe are still areas of active research.
Okay, so we've gone from these entangled coins and gloves to the nitty-gritty of quantum gates and the potential of quantum computers.
Yeah.
It's a lot to take in. What does it all mean in the grand scheme of things?
I think if we connect this to the bigger picture, entanglement is the key that unlocks the potential of quantum technologies.
Yeah.
Quantum computers rely heavily on it to achieve their computational power. It's what allows them to solve certain problems that would take classical computers millions of years.
That's the part that always blows my mind.
Right.
The idea that we could have computers that are exponentially more powerful than anything we have today,
Yeah.
all thanks to this bizarre quantum connection.
It's truly a game changer. And it's not just computing.
Okay.
Entanglement also plays a crucial role in other quantum technologies like secure communication, ultra-precise sensors, and even potentially new forms of medical imaging.
So the seemingly impossible connections between entangled particles could have very real-world applications.
Exactly.
It's like something straight out of Star Trek.
Yeah.
But it's happening right now.
Absolutely.
We're still in the early stages of understanding and harnessing the power of entanglement. But the possibilities are truly transformative.
Yeah, it's a whole new frontier of science and technology.
It's like we're on the verge of a new technological era,
Mm-hmm.
driven by this phenomenon that even Einstein struggled to accept.
Right.
It makes you wonder, what else is out there?
Yeah.
What other mysteries of the universe we haven't uncovered yet?
That's the beauty of science, isn't it?
Yeah.
There's always more to discover.
Right.
Entanglement forces us to rethink our fundamental assumptions about the universe. It suggests a level of interconnectedness that we're only beginning to grasp.
So what's the one thing you want our listener to take away from this deep dive into entanglement?
I think that entanglement is more than just a scientific curiosity.
Okay.
It's a fundamental aspect of the universe that has the potential to reshape our world in profound ways. It's
Yeah.
a testament to the power of human curiosity and our drive to understand the universe around us.
It sounds like we're just scratching the surface of what entanglement can do.
Yeah.
Who knows what incredible applications we'll discover in the years to come. I, for one, can't wait to see where this journey takes us.